Okay guys, so sum and difference formulas. There's a lot of formulas, there's 6, but you're not going to freak out. And actually they're really easy to remember once you start using them a little bit. You'll definitely remember the sine functions and the cosine functions. The tangent ones you'll get used to after like a couple times too. Okay, so after today you'll know them. All right. So go ahead and highlight these first. The sum and difference formulas, so basically this is if you have, let's say, something like, I'm going to give you a weird one, something like the sine of 15 degrees. So if you have the sine of 15 degrees, it's not on the unit circle, but you can use the difference formula, and if you do like the sine of 45 degrees minus 30 degrees, then that would be 15 degrees, right? So like 45 minus 30. This gives you the answer for sine functions that are not on the unit circle, where you can add and subtract things that you actually know on the unit circle. So the sine functions for addition is going to be sine alpha cosine beta, because they're two different angles. This is like 45 and 30 or whatever. So it's going to be sine alpha cosine beta plus cosine alpha sine beta. So basically, even if you reverse these and then you did like sine beta cosine alpha, it doesn't matter because you're multiplying. Even if you switched these two around, it wouldn't matter because you're multiplying. But basically, you take the sine of the first one, the cosine of the second one, and then you add the other ones. And then for the minus, you're going to do the same for the beginning, but you're going to subtract the other ones. So it's pretty easy to remember, okay? The cosine functions, so those, like once you know the sine ones, the cosine ones are pretty quick to remember too. So you can see it's cosine, cosine, minus, okay, so if it's addition, then it's cosine, cosine, minus sine, sine. And then if it's subtraction, then it's cosine, cosine, plus sine, sine. So you'll get used to it after a little bit. And then the tangent formulas, this is tangent alpha plus tangent beta all over 1 minus. And then these are the same things, but now they're multiplied. Okay, so you'll get used to it. And then you see like the plus, there's a plus on top, there's a minus on bottom. The minus, there's a minus on top, there's a plus on the bottom. So let me show you how they work. I'm going to go through the first page really quickly, actually. And then one more thing, the cofunction identities. You actually already know this. So basically the cosine of, let's say, 30 degrees is the same as the sine of 60 degrees, right? So this is saying the same thing. Instead of degrees, it's using, instead of like 90 minus, because that's in degrees, this is pi over 2 minus, because this is in radians. So you don't have to memorize these. As long as you know these, you'll be fine, okay? So example 1, and you can kind of see sine of 75 degrees. So we don't know what 75 degrees is on the unit circle. So we can do 30 plus 45. You can see how this works. Sine of 30, cosine of 45, plus cosine of 30, sine of 45, using the unit circle, and then multiplying them together, and then adding them if possible. So like this is fine, this is fine. There's different ways that you can write the same answer, okay? So a little bit different. So sine of 15 degrees, you can do this using, let's say, 45 minus 30. You can do 60 minus 45. Any two angles that you can use on the unit circle, you can use that to get your 15 degrees or whatever you're looking for, okay? So it just works out the same way. Cosine of pi over 6. I know that you know the cosine of pi over 6, but just so you can see how it works, this is how it would work with pi over 6. You would go ahead and do something like pi over 2 minus pi over 3, right? So you have to think of like, how do I get pi over 6? So a good example of that would be this tangent of pi over 12. Okay, so this is the tricky one. So pi over 12, you're thinking in your head, oh, how do I get a pi over 12 of things I already know? Well, if you do 4 over 12, that's really 1/3. So you guys know pi over 3. You guys know pi over 4. Pi over 3 minus pi over 4, if you change them into over 12 and over 12, that gives you pi over 12. So that's how you can get tangent of pi over 12. You can use these two, which are really these two, and then you're just using your formula that's above, and then you can see tangent of pi over 3, use your unit circle, tangent of pi over 4, use your unit circle, and then you have this one and this one. And then this is extra, right? So like this is your answer right here. But then that's not rationalized. So see that radical on the bottom? So we want to rationalize that. So you're going to multiply by the conjugate of the denominator. So we had talked about that today. So conjugate, and then when you multiply conjugates, you get a squared minus b squared. So you get 1 minus 3. And that's what we have on the bottom. On the top, you got to FOIL it. And then you get this. And then reduces, and then the -2, you can like pull out and then reduce, and then you get that, okay? Example 2 is similar. It's basically writing it in the correct form, and you have to tell, okay, what is this? And then you have to recognize this as a difference of signs. So if this is a difference of signs, then this came from sine of 80 degrees minus 20 degrees. And then, so looking at this, you're like, oh, this is, 80 degrees minus 20 degrees. So really, 80 minus 20 is 60. What is the sine of 60? Oh, it's root 3 over 2. Okay? So same thing for this one. You're thinking, where did this come from? Oh, it's the sum of tangents. So this is the original. And then you go backwards. You like add them together and you get this. That's really that. And then now you know the tangent of 3 pi over 4 is -1. Okay, so that comes from the unit circle. So this is going one way, like, hey, I want this, give me an answer. And then this is going the other way where they already plug everything in for you, and you have to decide, oh, what numbers are they using and what formula are they using, and then actually get that answer from there. Okay, so I think these are kind of easier. All right, so the ones that you're actually going to copy. Okay, so these are a little tricky, I will say. So the first thing is that this is the given, okay? So given the sine of alpha is 4 over 5, and then this gives you the parameters, like this alpha is between this angle and this angle. So between pi over 2 and pi, we are in quadrant 2. So you can see that I drew my triangle in quadrant 2. Why did I use a triangle and not a unit circle? Because it's not in the unit circle. So then I drew my triangle in quadrant 2. I make sure to have that right angle on the x-axis right there. And then my alpha, make sure it's alpha. Don't use like theta or anything because it says alpha. My alpha comes from the origin. So you have the sine is opposite over hypotenuse. And then you had to think of this number, that's a -3 because it's in quadrant 2, because that says it's in quadrant 2. And then now here's alpha. And then you're going to do the same thing for beta. You're going to draw a picture for beta because that's not in the unit circle. Beta is in quadrant, you think about this and you're like, okay, between pi and 3 pi over 2, that must be quadrant 3. So in quadrant 3, you're drawing beta, and this is your x value, and this is your hypotenuse. So here's your beta in quadrant 3. So quadrant 3, and then x value, hypotenuse, and then you have to use Pythagorean theorem to get this value. You know it's negative because it's in quadrant 3. Okay, this is your picture for beta. This is your picture for alpha. You're using these two pictures to fill this in. So the cosine of alpha minus beta, use the formula. And then now the alpha, cosine alpha is, and you look over here, oh, it's x over r. And then cosine beta is, and look over here, x over r. So then you're just filling that in, go ahead and multiply, rationalize if you have to. Okay, same thing over here for tangent. So it just works out the same way. You're using the picture. So, well, first you use a formula, and then you're using the picture to fill in tangent of alpha, opposite over hypotenuse, or sorry, opposite over adjacent, tangent of beta, opposite over adjacent, and then you keep going, and there's no answer there. Oh no, there's no answer there. Okay, I'm not going to stop and do it. You guys figure it out, and then you check with each other. Okay, sorry. Okay, example 4, proofs. Okay, so there's more proofs, but now we have these formulas that we can use. So we want secant of alpha minus beta to equal all of this stuff. Secant alpha, secant beta, all over 1 plus tangent alpha, tangent beta. Okay, obviously this is more complicated, so I'm going to rewrite that. And then using this, I need to like do something with it. So what can I do with this? Okay, secant. Oh, secant is 1 over cosine. So then I replace that with 1 over cosine, all over, and I made this a little bit darker, all over 1 plus, what is tangent? Oh, it's sine over cosine, so sines over cosines. So now this is a complex fraction. I want to have the same denominator in my whole fraction. So the top has cosine, cosine. The bottom, I need it to be cosine, cosine also. So the bottom, in order to make this cosine, cosine in one fraction, then I need this to be cosine alpha, cosine beta over cosine alpha, cosine beta. So if I do that, then I have cosine alpha, cosine beta plus this numerator all over the same denominator. Once you have the same denominators, you can divide the denominators away, right? So you have left 1 over that as your denominator. Well, this is the cosine minus formula, the difference formula. And then what is 1 over cosine? Oh, it's secant. That's where we want it to end up. So there you go, with the happy face. So more proofs, practicing the proofs. Okay, so B is a little bit different because for B, and I do want you to write this even though there's a sad face, okay? So for B, if this is the beginning, I would probably start here and I'd be like, oh, well, I can just use the formula for tangent sum. So here's my formula for tangent sum, and then there's nothing to do with it. Like literally you get stuck. So that's why there's a sad face. So I want you to draw that sad face, okay? Sometimes it's not gonna work out. Sometimes you gotta try something else. You're gonna do work and then you're like, I can't make it work. I can't make this equal to that, okay? So instead, we start here and then we go, okay, what else can we do with tangent? Oh, it's sine over cosine. So then if you have sine over cosine, okay, well, what can I do with this? Oh, these are formulas. So here's your sum formula, you write it all out, And then what is sine alpha cosine 1/2 pi? Cosine of pi over 2 is 0. 0 times anything is 0. Sine of pi over 2 is 1. 1 times anything is itself. Same thing on the bottom, you get this. And then cosine over sine is cotangent. And that's where we want it to end up. That was supposed to be an alpha. Sorry, that was supposed to be an alpha. I looked at it and I was like, oh, it's supposed to be the same thing. Okay, last example. Find the exact value of this right here. So this is the question. This you can do on a unit circle. This you cannot do on a unit circle. If you can't do it on a unit circle, you need to draw triangles. So this one, you need to draw one triangle. If this couldn't be done on a unit circle, you would have to draw another triangle for that one. So this is how I label it. If I can do this on the unit circle, I go ahead and do it. Cosine inverse of 1/2 is pi over 3. Sine inverse, I don't know what that is, but I'm going to say that's theta. You can call it alpha, you can call it beta, you can call it whatever you want. But that's going to be my picture. So thinking about this, just like the way we drew pictures for 6.2, this is in quadrant 2, or sorry, this is in quadrant 1, sine inverse of 3 over 5. So you draw that here, and then you get your other side, right? This is opposite over hypotenuse, and then you get your other side. It's a 3, 4, 5 triangle. Oh, that makes it easy. So here's one of the angles, and then theta is this triangle right here. So really what they're asking is the sine of pi over 3 plus theta. So I changed the question to sine of pi over 3 plus theta. That's what we're really looking for. Use the formula to write it out. And then what is the sine of pi over 3? Unit circle. What is the cosine of theta? You use the triangle. It's adjacent over hypotenuse. There you go. Using the triangle that we drew on the right side. Same thing over here. What is the sine of using the triangle? Sine of theta. And then cosine of pi over 3 is 1/2. And then you multiply, you get this, or you get this. You can have lots of different answers. It doesn't have to be exactly the way it's seen in the book. You just have to make sure you rationalize it. All right, I know that was quick, but you're going to try your best. And then this is due after your quiz. So good luck, help each other. All right.